Welcome back to my channel. So today we are going to look at another DSA problem, container with most water. So let's go. It's again an array problem. So you are given an integer array height of length n. There are n vertical lines drawn such that the two endpoints of the ith lines are I0 and I2 height. So these are the vertical lines and these are represented by the array which you see here. It starts from 0 and it goes up to the height as mentioned in the array. And we need to return the maximum amount of water a container can store. So a container is something with a left boundary and a right boundary, as you can see, the ones highlighted in red. And the blue portion is the amount of water, the maximum amount of water that is carried, right? So that is calculated simply by area. So that is length into breadth. So this is the length, right? And this is the breadth. So if you notice something, the smallest height or the vertical which is considered is this one, because this determines the level of water, right? The higher boundary does not determine the level of water. So this has to be considered, whatever the length of this is and the boundary. Now let's look at the constraint. Okay, so n is less than 10 to the power 5, so we can't go for n square solution because that will give us 10 to the power 10 and that will give us a TLE. Okay, so let's briefly discuss the brute force solution. So in a brute force solution, we'll have an array and we'll have an inner array, right? And that will be running with I plus 1, so that these two boundaries are considered, right? And using this, you have to calculate the area or the amount of water that will be collected in this container. So the height will be determined by the lower boundary, that is this, that is going to be 1, and the breadth is just going to be uh, j minus I, right? The distance between the two. And we'll be calculating the maximum area and returning that. Let's quickly code it, I mean the brute force way, just for understanding it better. J will be I plus 1, so that the first boundary is considered. And let's have max area is equals to 0. And when we are calculating the area, so area needs height into breadth, and as mentioned, height will be the lower boundary between the two. Why? Because this is what determines the level of water, and that is what we are interested in. So this is the height, and that needs to be multiplied by the breadth. Okay, let's calculate the max area. And we just need to return that. So this just runs fine. I'm not going to submit it. I'll get a TLE. So this is obviously not an optimal solution. This is the brute force solution. So for the optimal solution, what we need to do is we need to consider two pointer. Okay, we need to have a start pointer which starts with 0 and an end pointer. Okay, now while start is less than end, we are going to do the same thing. We are going to calculate the area. Area is minimum between start and end into end minus start. And again, max area needs to be calculated. That is going to be max okay. Now we need to increment or decrement our start and end pointers, and how we are going to do that. So we will be checking whichever is the lowest, and we will be incrementing that. If height start is less than height end, then we are going to increment start, else we are going to decrement end, and we just need to return max area. So why we are doing this? Okay, so basically whichever is the smallest, right, that is the determining factor of the level of water, right? So that is why this has to be incremented. I mean, this is the lowest here when we are considering for the very first part this vertical and this vertical. So this will be incremented. So how this helps is you can consider the reverse situation first. What if we wanted end to be decremented? So even if we decrement end and we come here, the height will be determined by the lower boundary, right? This will be the level of water. So it kind of makes no sense decrementing the higher boundary. And again, if suppose the very next boundary next to the higher boundary was something greater than that particular boundary, again the height of the water would be determined by the lower one. And also, if you consider the area, the breadth would be shorter, right? Because initially we are calculating the breadth from this point to this point, and the height, that is 1. And if we are decrementing from the higher boundary, we are just shortening the breadth. So our area becomes comparatively less than the first one, and that is not what is expected. We want the highest area, maximum area, right? So this does not make sense that we have to decrement the higher boundary. Similarly, if you have to consider what happens when we shift the lower boundary, when we are shifting the lower boundary, that is this is the shorter boundary that we got, and we are incrementing. So we'll have a chance to see a vertical line which is greater than the previous one, and it might have a greater height, right? So that could compensate for the difference in breadth, right? We can have a greater height, and so our area would be more. So decrementing the higher boundary does not make any sense, but that's why we go for incrementing this. Let's just run this. and submit. Okay. So I'm hoping you understood this question. Thank you so much for watching. Let's catch up in the next video.